Let's see an example of how we can get a result back from something running on a different thread using a callback. Java provides nicer ways to do this using future and callable, but I won't be getting into those in this video. So in case you missed the last video, we saw that performing a task that can take a noticeable amount of time directly on the user interface thread can make your application appear as if it's frozen. So we used a download example where going to download something from the internet can introduce some network delay. So our solution was to perform the download on a new thread so that our UI thread can continue. So in this class, it's pretty simple. We just set up our frame, add the button, add the click event, and later we'll be adding the callback. So our download has been moved to its own class, which implements runnable. So in its run method, all it does is simulate 3 seconds of network delay and pretend to get some download text, and then send it back by calling the callback method. So it's a little tricky, but essentially how we do the callback is in our download class we declare this interface that says if you're going to be a callback, you need to provide some code that implements this IamDone method. So the IamDone method is a method that gets called once we're finished downloading, and it takes the download text as a parameter. So here we have a field of callback because the class that's creating this download runnable needs to give it some sort of indication of which method to actually call. So our download UI class, for example, is going to be the one creating this download. So the download UI decides where this callback method should live over here, and then when it creates the download, it passes that into the constructor. Because it has this in the constructor and assigns it to a member field, when the new thread starts and calls the run method, we know and can access the callback method. You might be asking why we can't just put that directly in the run method, and that's because the runnable does not declare the run method with any parameters. So in order to be runnable, your run method has to look exactly like that. So let's see how this works. So from our caller class, and we could do this the anonymous way instead, as I demonstrated in the last video, but this time I'll do it by implementing the interface provided by download. So download.callback. So now we implement this callback interface, and now it's complaining because we need to actually implement it. Okay, so here let's just say download complete, and then print out the download text. So now when we run it, nothing will happen. Well, the button click still happens, but we haven't wired this up yet. So to do that, let's say new thread, and then we'll make an anonymous download. So we'll say new download, and we need to call start. So download's complaining because in download the constructor is expecting a callback method. So what do we pass it? Well, we can just pass it this because this is the download UI class, which is a callback because we have implementation for the IamDone method. So now, when we run it, we download and our callback happens. So that's a pretty simple yet tricky way we can set up our own events and take action when things are fired from different threads. Lastly, though, I'd like to introduce an issue that comes along with this. So anything can call the IamDone method in download UI because it's public, so this method can be called from within this class, from other classes that have access to this instance, or we could have multiple downloads. For example, we could start 2 downloads, and for both downloads we pass it this class, which only has 1 copy of this IamDone method. So what does that mean? Well, let me change the code and show you what can happen. So change this to sender, and we'll change this to entered, exited, and let me introduce some delay so we can see what's going on. And here, rather than getting some fake download text, let's pass it some unique value so we can tell which runnable was the actual download that called the callback method. So string name equals string value of. So this won't be pretty, but getting the string value of this will be essentially the address of this specific instance of the download object or download class. So back here, now we can see which unique sender called the callback, when they entered and when they exited the method. So if we run it now, we can see 2 different things entered the method at the same time, or operating in the method at the same time, and then exited. Depending on what you're doing, this can be problematic because it introduces what's known as a race condition. So a race condition is basically when a single data object is accessed and modified by more than one thing at the same time. I won't get into too much detail, and you can look into race conditions on your own if you'd like. But basically, the race condition is a problem because when multiple things are changing the same thing at the same time and we don't know what order it's happening in, usually you'll get weird behavior, and usually what you're trying to do won't actually work. So yeah, you can look into that more on your own, but basically it's bad and usually causes problems. So let me add a couple more threads, and I'll change this to 5 seconds. So okay, we have 4 threads, possibly manipulating the same things at the same time, and then they exit. So we can fix this by introducing a new keyword called synchronized. So basically what synchronized means is once a thread gets access to this method and calls it, it obtains a lock on the method. So if we have thread A and thread B, if thread A calls this method, because it's synchronized, Thread B will not be able to enter this method until thread A is completely finished with every statement in the method and exits and releases the lock. So it's a way to make sure that it's just accessed one at a time. So let's watch the print statements. So we enter, and you can see only one method gets to operate in, one thread gets to operate in the method, and the next thread can't enter it until the previous thread is completely finished.